So welcome to part 7. This is going to be 7B, or the second part of Negative Sequence Made Easier. And this is particularly going to be going over the follow-up to the IQ 1000 relay. In the last video, we went over how to get all of these variables defined. This is for the pickup, and then this is for the time delay. And we defined everything in the last video, so if you want to figure out how we got this information out of the manuals, that's there. We also went over an example for the time delay, a little quick, but we went over it. And we're going to use these settings right here to do the testing, okay? Now, I do want to say that the way that I like to do my unbalanced testing for currents is going to be we inject balanced angles, so I don't like to mess with my angles if I don't have to. I'm only going to vary one current magnitude, and then all the other magnitudes are going to stay at FLA. And usually what I do is I change A phase. IA is going to go greater, 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 but IB equals IC equals FLA at their respective angles, okay? And then this is, for this equation, we're going to need, this is positive sequence. So we're going to have to square that, and we're going to have to square this. And you're going to see the math's going to get pretty ridiculous. And so we'll hop over to a whiteboard, but this is the information that you're going to need in order to start in this whiteboard. This is our initial equation. And then here's, we know that our ultimate trip level is going to be our FLA times service factor. And then this K is 6.01. So we could substitute all of that in here. And remember, this is I squared. So this is really, both of these are squared. That's what we got here. And then you've got the rest of it all right here. Now, as I said, with the way that we're going to do this test is we're going to start with all three phasors 100% balanced at FLA. What we're going to do is we're going to leave B phase and C phase. We're going to leave them alone. We're just going to slowly ramp the magnitude of A phase, not the direction. The direction still stays at 0, but just the magnitude. So that's what we're trying to define. And so given that, we know that some of these variables, honestly, are already defined for us. It's not too terrible. So let's do some tricks. I got some tricks in here to help us narrow this down. So this is I1 right here, just all written out. And what I did was I went in there and I said, look, we already know B and C phase are going to stay at FLA, right? So we might as well just leave them there, give them their angle compensations, and figure out what it's going to be. And lo and behold, when you go ahead and you say, hey, FLA at minus 120, and then you have a 120, it goes back to 0. And we want everything to be in 0 degrees because our final answer is going to be some magnitude of A phase at 0 degrees. So this becomes FLA and FLA, add them up. Now you have 2 FLA. This is essentially I1, and then, we need I1 squared. So we're going to square all of that, and that's what's here. And yes, it starts to get a little stupid. You'll see it later. This right here is the final, what we're going to use for all of our our I1 squared. Now let's do the same thing for I2. This gets a little sloppier, but there's a trick that we're going to do here. We have FLA, look, B phase and C phase are going to stay. They're not changing, right? So we can do angle compensations. However, we get FLA at 120 and FLA at 240. So we have to do a little trick here. And it's actually 2 tricks. So what we have is one of them is right here and the other one is right here. Now, A phase is off to the right. We don't really care about A phase right now. If you were to do the math, we know that we're staying at balanced angles, right? So since we're staying at balanced angles, one of these is going down just as much as the other one's going up. So the vertical element's going to cancel out. And what you're going to be left with, if you do the numbers and you really crunch it, one of these is halfway, the other one is the other half, and all of a sudden you're back to FLA at 180 degrees, which is right here. Or since we want everything in compensations of 0 degrees, FLA is going to be, it's going to be minus FLA at 0. We could do that as well. Both those are equivalent. Okay, so crunch the numbers with the Cartesian coordinates if you want, but what you get is this right here, which is going to be IA minus FLA at 0 degrees. Now we're going to square that, and that's what you end up right here. So now we have both I2 and I1 squared, and we have our beginning FLA, we have our K value. We're just going to substitute everything in, and so that's what this monster ends up being right here. And I'm going to have to zoom out quite a bit. So that's what all of this is. This is everything substituted in, and you can see it's a monster. So the first thing I do is these were both, 1/3 and 1/3 squared. It's what you got up here. So the final resultant was a 1/9 on both the I2 and the I1. And so what I did first was I just multiplied everything by 9, and that put that over here with the FLA and got that little number out in front, and we no longer have that here. Okay, so I'm just trying to simplify where I can. And I also combined like terms if I saw any. And then the next thing I did was I moved all of this to the other side, which is over here now. So now it's a -9. And then what we started doing was distributing terms. The 6.01 also distributed out to each one of the terms in here. And then that's what you've got right here, here, and here. And then you can see I've underlined this term and this term, well, they're both an IA squared. So this is there's just a scalar in front of them. So you can combine them. It becomes 7.01 IA squared. That's what that is. And then the next one is this one right here and this one right here. Those are just IA times FLA at 0 degrees. And so you combine them and you get this right here. And then the last one is this one and this one. And those also combine. They're just FLA squared. Okay. So you combine those and you get all of this business right here. And then this service factor just right here, just carried down. That's all we did. And so the next thing I did was I said, hey, now let's take a step back. And when you do some high school math, you might run into this equation right here, which is the quadratic formula. And I said, look, we've got IA squared, we've got IA, and then we've just got some other number. So let's just go ahead and pretend that it's like this guy right here and just substitute the values. So that means that 7.01 is A, 8.02 FLA is B, and then C is going to be all of this right here. And if you substitute that in to this formula right here, then what you get is going to be all of this business right here. And you can see, yes, it's another mess, okay? But it does simplify down. First thing we're going to do is simplify those negatives, multiply this out, and then I took the square and I squared that and I put FLA squared right here, okay? So there's that. And then I also expanded that out. All right, that's all we did. From here, what we did was I said, well, we've got FLA inside, and it's FLA squared, FLA squared. You could just say, let's undistribute that, and then it's just FLA squared inside. Well, let's just take the FLA squared and just make FLA on the outside. Now, this is a common trick in math for equation manipulation. And later on, you can see that, hey, I've got an FLA in this whole term and an FLA in this term. So I just took the FLA and the 14.02 on the bottom out of everything and put it out on the side. The 8.02, now we can write everything bigger. And what I did was I just went through and I said, let's distribute this out to each of the terms here. And then don't forget that this negative becomes a minus this number and a positive this number. So then you can combine these terms on the next one, which is what we did right here and here. And then, okay, so now we're down to just some basic variables, right? And this essentially is IA at an angle of 0 degrees. And so, and just using the variables inside the relay. So we substitute our situation, which I told you, this is what we're going to calculate it as. Service factor is 1.1, FLA is 2.5. Substitute all of that in here. And then now let's crunch the numbers. You get all this. And what I did was I tried to keep a lot of numbers on this. And if we round too soon and we don't keep enough digits, we're not going to have a good accuracy. What we see is that we have a plus or minus here, okay? And that's important. So we have to do this both ways. We have to add like here, and we have to subtract right here. And so when you solve both directions, this one becomes a positive 3.11 amps at 0 degrees. And then this one is actually negative amps or 180 degrees. And I told you we wanted to keep A at the same angle. So we don't want to go to 180 degrees. So what we're going to do is this one right here. We're just going to go from FLA at 2.5 amps to 3.11, and it should pick up. So we said this is how you're going to perform the math, the test. You're going to start here, and you're going to do a ramp that hopefully ends and picks up right here. Okay. All right. Now, can we prove the math? So if you go into a phasor calculation and you type these, these numbers in, right? FLA, this is what the final value is going to be. What is our final positive and negative sequence calculation going to be? This is what it's going to be. You can go into any online tool and find these, and you can prove it, right? So let's go ahead and put that back into the original equation, right? The positive sequence, negative sequence. I substituted everything back in, and then I said, hey, all of our angles are at 0, so I'm just going to drop this 0 degrees just to make our math smaller. And you get to this right here. And so all we have is just a bunch of magnitudes, really. And you square everything right here. And then this right term, you're going to multiply by 6.01. You get this, and this. And then you have to add these two right here. It becomes this. And this is just an amp squared. That's just for the units, okay? That doesn't mean that this number is squared. We've already squared the number. But if you look, this number and this number are the exact same. I mean, it's just a rounding error, okay? So really, if you are going to apply the situation, if you stick with you start at FLA and you raise one vector, one phasor, and let's just say IA, and you leave all your angles balanced, you can use this equation right here, substitute your variables and use from the relay, the settings themselves, the FLA and the service factor, plug that in, and you can calculate where your A phase should pick up.